Leetcode 73, set matrix zeros. It's a medium type problem, or at least they claim that it's a medium type problem, but I would say that it's rather an easy problem because it doesn't really require any advanced techniques that are usually required from medium problems, such as some entry-level graph theory like trees, or maybe backtracking, and maybe some dynamic programming approaches and so on. And here you can basically solve it just using loops and arrays, which should be very basic knowledge that anyone that has completed even the first semester of computer science should have. Yeah, so definitely one of the easiest mediums out there. And here is the description. Given an m times n integer matrix called matrix, yeah, so we have, or at least we can have, different number of rows and columns, yeah, versus number of rows then number of columns. And if an element is 0, so the matrix basically has integers inside, they specify it here, and those integers could be 0 as well. And if we encounter 0, then we have to set its entire row and column to zeros. And here's an example below with some graphical representation, which is always welcomed. And in the middle you have 0, and because it's in the middle, you have to set the whole column and the row to zeros. Yeah, not because of it's in the middle. You have to do it either way. Yeah, wherever it's placed. And that was the only 0. That's why only single column and single row was zeroed. And here the matrix was square, but as you can see, m times n, so it doesn't have to be square, and that's the case in the second example. You have a rectangular matrix, and we have 2 zeros, so 2 columns get turned to zeros only, and 1 row. That's because, of course, those cells can be in the same column or in the same row. Yeah, it can be repeated. And it could be also the case that all the cells in the given column or in the given row are already zeros. Yeah, so it's not necessarily the case that we have to change anything. We just have to make sure that by the end, if there is 0 in any cell, then its full row and its full column has to be set to 0. Okay, so let's maybe copy this part and think about some efficient way of solving it. We can turn it to more matrix-like representation. Yeah, like this. And the output following. Let's also make it more matrix-like, a little bit bigger. And here was our 0. Yeah, and that's why we turn the row and the column to zeros. Yeah, so that's our task. And one more thing, we have to do it in place, meaning that we have to modify the matrix that is given to us as an input. We don't return anything. Yeah, we just have to modify the input itself. And there are some follow-ups. A straightforward solution using m times n space is probably a bad idea. A simple improvement uses m plus n space, but still not the best solution. Could you devise a constant space solution? Okay, so we will try to do it in m plus n space and m times n time complexity. And basically the idea is following. Let's do 2 iterations. The first iteration we will just mark rows and columns will be changed. And in the second iteration, there will be like 2 passes, and or maybe 2 passes is better way. since we will use, of course, nested loops. Yeah. So whenever we have a 2D matrix, we have to use nested loop in order to access all the cells. And the first or the outer loop is taking care or tracking the rows, and the inner loop is tracking the columns. Yeah, and of course, once we have row and column, we can get any cell. So that's the idea of using nested loops. And in the second pass, we'll update if was marked. Update the cell if its column or row was marked before. So basically that's it. We will track separately. For this, for rows, we will use one additional container, one additional list, and for columns we'll take one additional list. Basically, we can set it, initialize it all to false, and have as many cells as there are columns and as many cells as there are rows. And once we iterate through each cell, if we ever encounter 0, we will simply swap the false on appropriate index in both the row marker and column marker to 0, and then we will use it in the second pass to update the whole row and column. So that's more or less the idea, and we could do it here, but I think that because it's such a simple problem, we can already start writing the code. Let's do it in the following way. So rows to, or maybe marked rows like this, and marked false, and we will have m length of m, m cells initialized to false, and n cells initialized to false, because m is the number of rows and n is the number of columns. And of course we could swap it, but because they already use this notation here, let's not confuse. But we have to extract it ourselves from the input matrix, and of course number of rows is the length of the matrix itself, and the number of columns is the length of the first row. And now we can have the first pass marking without modifying or with no modifications to the input matrix. Yeah, and as I said, we will use two loops. First is the outer loop for I in range m, that keeps track of the rows, and then is the inner loop which keeps track of the columns. And if given cell matrix on position I and j is equal to 0, then we have to mark appropriate row to be removed and appropriate column to be removed as well. Let's move it here and copy from here. And that's already the first pass. And the second pass is modification. And we do the same thing. Two loops, outer loop and inner loop. And if given row has been marked or current column has been marked, then we update the matrix on that particular position, I and j. And sorry, here should be j to 0. That's it. Now let's run. And the runtime is 0 millisecond. The first two cases are correct. Now let's see on all the cases. Yeah, and we beat 71% when it comes to the runtime, but only 17% when it comes to the memory. That's because there is more advanced solution that is using less space. Yeah, but I prefer this one because of the simplicity and because it's still more or less fast.